Let's play ancient explorers, those who took courage and sailed the open oceans to discover places no one had seen before. Our ancestors found the universe small and simple. They blamed the moody god Poseidon for the tides. Lightning came from the forge of Vulcan, the god of fire. Amor sent them love, and Apollo, epidemics. That was the universe of ancient Greek and Romans. Astrologers had their own view of the universe as well. They thought our lungs were influenced by Gemini, good stomach by Cancer, heartbeat by Lion, digestion by Virgo, and kidneys by Libra. Javanese people saw a great warrior, the giant Bhima, in the bright and dark areas of the Milky Way. The same Milky Way was a hollow trunk lying on Earth for South American Indians. And the San people believed the Milky Way was formed when a girl scattered glowing ambers in the sky. Nowadays, everything is different. We are the people of modern times. The sky has filled up with equations and technical symbols. We know very well that the universe is very old. It emerged some 14 billion years ago. And that the universe is very large, too. So large that human affairs seem insignificant next to it. What you are about to see is the result of human studies of the universe. No superstitions, but science in its purest form. The universe is so large that measuring it in kilometers makes no sense. Instead, we have to use the distance that light travels in 1 year. A light year is about 10 trillion kilometers long. Is it a little or a lot? Imagine as if the distance between Earth and the Sun, which is 150 million kilometers, was the width of your thumb. In this case, a light year turns into a 1.5 kilometer journey. That is a lot of thumbs. The star closest to the Sun, Proxima Centauri, is 4 light years away. And even on our thumb scale, that's already unimaginable. But we're going to travel even further. And it won't matter if we estimate the distance in thumbs or light years. We're going to fly further than the boldest explorers have ever dared to. We've stopped. Do you see anything? Nothing? That's what a typical place in the universe looks like. Vast, dark, and very cold darkness. Compared to the eternal light of intergalactic space, stars are beautiful lights of hope. Our galaxy. Just beautiful, isn't it? A space island that comprises all the stars you can see in the night sky without a telescope. All nebulae, the whole solar system, our planet, and of course, us, people as well. We would have to travel 1 million years to get to such an intergalactic view. This is our home. The diameter of our galaxy is more than 100,000 light years. Do you remember our model, where the distance between the Earth and the Sun shrunk to the width of one thumb? In such a scale, our galaxy would extend almost as far as the Moon. Our galaxy is the home of 500 billion stars, and the Sun hovers in it like a tiny speck of dust in the morning fog, completely lost. Somewhere here. What does our galaxy look like in infrared light? Or if we put on a pair of ultraviolet glasses? Infrared radiation enables rattlesnakes, pythons, and other night snakes to sense the body heat of their prey. We use it in TV remotes and to detect heat leaks. When seen in infrared light, our galaxy reveals cool objects, like young stars or clouds of cool dust. Sun-tanning ultraviolet radiation is important for insect, rodents, and birds. Hot objects, like giant stars and clouds of hydrogen gas, get brighter in ultraviolet light. In visible light, the most noticeable of the galaxy is a flat disk filled up with shining stars, dark clouds of interstellar matter, and clouds of hot hydrogen. And it's the disk that creates the gently hazy Milky Way in Earth's sky. In the galactic center, there is a supermassive black hole of more than several million solar masses. It's surrounded by a cloud of inconspicuous red dwarfs, cool cores of extinct stars, and beautifully symmetric star clusters. Our galaxy is not alone in the universe. There are other galaxies further away. Some of them look like pancakes or rugby balls. Many of them seem torn to pieces. We estimate there are about 1 trillion galaxies in the observable universe. We already know our galaxy contains about 500 billion shining stars. Is that a lot? Not really. After all, there are more grains of sand in one big sandpit. Some stars are small, like a medium city, but they are 100 times denser than lead, like this neutron star from the constellation of Taurus. Other stars are real giants. On their surfaces, we can see giant bubbles of hot gases interspersed with cool areas, many times bigger than our sun. This buddy, from the constellation Orion, called Betelgeuse, is going to explode as a supernova soon, maybe tonight. Some stars shine like torches to the distance of many thousand light years. They are so big that the sun is just a shining speck of dust next to them, like Deneb, a star from the constellation of Cygnus. Many stars don't live alone. A lot of them form pairs or even bigger groups. If we looked at them and sped up time, we would admire amazing ballets of shining objects dancing around their common centers of gravity. Many of the stars have color shades visible at first glance. Red is typical for cooler stars, blue for hotter ones. At first glance, they look like shining diamonds hanging on an invisible necklace of gravitation. Stars can also form star clusters consisting of dozens of shining objects. And it doesn't happen just by chance. They all emerged from stellar nurseries of interstellar dust and gas. In a similar fellowship, our sun was born 4.5 billion years ago. But there are even bigger systems, with hundreds of thousands of stars, affecting each other so intensely that they've formed huge spheres. What would the starry sky look like if we were on the edge of a faraway globular cluster? Incredible. There would be 30,000 stars in the sky, which is 10 times more than in Earth's sky. Although it doesn't seem so, the space between the stars is far from empty. Do you see the fine web? It appears dark and opaque when viewed from the outside, but hiding inside, there are hot, young stars. Stars are born in clouds of gas and dust, like this one, in the constellation of Orion. Like fireflies, they group into new star clusters, as well as solitary worlds moving around. In a similar place, the whole solar system was formed 5 billion years ago. Our sun, planets, minor planets, comets, and in fact, us, humans, emerged in cocoons like this one. dust you are, and to dust you will return. We must remember now. Nothing is forever, not even the stars. Once they burn up all their thermonuclear fuel, they cease to exist too. They either disperse or explode. In each case, it's an amazing spectacle. Ethereal remains of a star that once was like our sun. But the most massive stars come to their end in an even more remarkable way. Everybody knows the term, a black hole. But what is it? The strangest place in the universe. A place where sci-fi becomes reality. From this distance, we can look at a black hole quite safely. At first glance, we can see it's an extremely dense place, warping the structure of space and time. Like a giant lens, it shows us deformed light of faraway stars and galaxies. And vice versa, a shining flat disk in its immediate vicinity creates streams of extremely hot gas, traveling to a boundary called the event horizon. From there, nothing can escape a black hole. Not even light. And there's nothing faster than light in the universe. And a black hole? Of course, it's invisible, lying in the middle of the greatest darkness. But in neither case is it a sad graveyard. On the contrary, the atoms and molecules our human bodies are made up of, and actually the whole world around us, were once part of stars and nebulae formed by the stars. At the end of their bright existence, they supplied the universe with the elements necessary for life, whether in the form of dispersing nebulae or through explosions preceding the birth of a black hole. We, people, are not only genetically connected with our ancestors, but in the form of atoms of our bodies. We are connected with the entire universe. Every star can also be the sun for somebody. But what do these faraway worlds look like? They may be gas giants, many times bigger than Jupiter, decorated by amazing rings. Or rocky planets orbiting around two suns at the same time. They may travel very close to their parent star, with surfaces so hot that molten rock replaces water. There must be planets that look like white balls, covered by thick ice. about this cyan planet and its atmosphere with flying tiny specks of glass. We mustn't forget comets, ice balls decorating many skies. This is another rocky planet. Its scorched surfaces, heated by a distant star, is covered by craters, deep cracks, and huge cavities. A rain of sulfuric acid falls down from the dense opaque clouds of this world. Its surface is so hot that it glows red like a hot stove. A lot of planets are decorated by rings. This one probably formed from the debris of broken up moons. It consists of many tiny grains of ice with boulders as big as a family house wandering among them. Most of them are of ice origin. Just melt them and have a drink. Have you realized our trick? We've come back to our own solar system, in our beloved home, in the gravitational arms of our sun. We've been basking in its light along with the other planets for 4.5 billion years. We don't know if there's any other life out there in the universe. And if so, if it's based on the same principles like the life on Earth. Hopefully, we'll find the answer to this question one day. already know very well that we are just a negligible part of the universe, and the universe is part of us as well. In the deepest sense, we are all children of the cosmos. We have nothing else but this world. Beauty with 8 letters. Universe. We are the universe. English narration by Robert Polo.